Okay, welcome. It's 9 o'clock. Let's get started on time. Our first speaker today
timetable.
The speaker has until 9:30, so I need to stop him at 9:25 to give time for questions. So I need to warn him 1 minute before that.
Advise speakers before the session.
Morning, everyone. So you've got 25 minutes each for your talk, and then 5 minutes for questions. So you've got 25 minutes each for your talk, and then 5 minutes. I better warn you, I'm 5 minutes of questions. Everyone. So you've got 25 minutes each for your talk, and then 5 minutes of questions. I better warn you, I'm quite a strict chairman, and so I'm going to interrupt you about a minute before the talk finishes, and stop you once the 25 minutes is up.
Interrupt and stop.
Take another look at the slide I showed you before.
1 minute.
Thank you. This slide shows, in the next few slides, what I'd like to show you is the exact details of the process.
I'm sorry, but I'm going to have to stop you there because we've run out of time. Well, thank you very much.
Okay, well, thank you very much. I'll end things there. Process.
I'm sorry, but I'm going to have to stop you there because we've run. Out of time. So thank you very much.
Okay, well, thank you very much. I'll end things there. Thank you.
Be ready with questions.
Okay, so we've now got 5 minutes for questions. And I'd like to start by asking you about a slide.
So remember,
Hello? Yes. Okay. Okay.
events on time have a highlighted timetable. Advance.
Good morning.
Good morning.
Hello,
Hi.
my name is Wafa. So I will be
Yeah.
the first presenter in this session.
Yeah. Thank you for joining to the session.
Thank you.
We're going to start sharp 10. Okay, get
Okay.
ready. I already allocate for you as a co-host. So you can share your screen and you can present, okay?
Okay, thank you.
Right.
So can you hear me clearly?
Yeah, I can hear you clearly.
Okay.
Do you have YouTube link? We already sharing these things in YouTube live. Okay, good morning, everyone. It's 10 o'clock. Let's get started on time. Today, our first presenter is going to present about exploring generative adversarial network for entity search and retrieval. Before starting the presentation, let me give some instruction for you. Each presenter will get 15 minutes for his presentation, and 5 minutes is allocated for question and answer session. I'm going to remind you, once your allocated time going to finish before 2 minutes. Once the time is over, please allow me to interrupt you to stop your presentation. Then I will move for question and answer session. I am sorry that if I have to stop in time because other participants need to present. So let's get start. It's time for presenter 37. You can start your presentation.
Thank you. Good morning, everyone. I hope everyone can hear me.
Yeah, I can hear you.
Okay. So my name is Wafa. and my presentation will be about exploring generative adversarial networks for entity search and retrieval. Right, so our outlines would be, first we will introduce what is exactly entity search and retrieval, then talk about generative adversarial networks, and then explain our experiments and settings, and finally results and discussion. First of all, what is exactly entity search and retrieval? So if you see the picture in your left side of the screen, it shows a results of searching Google in the Google search engine many years ago. So basically, when we try to find something in Google, we get links of documents, and usually we have to search for the answer inside these links. But these days, what we see is once we want to find something on Google or other search engines, we can find something that looks like a card in the results. And this card is actually the entity that we are looking for. So this is exactly what entity search and retrieval is. It's the task of extracting real-world entities such as people, location, or organizations, or other things as the answer of our queries. So instead of getting documents and links, what we want to get is the exact entities as the answers. For example, if we want to find about Jeju Island, we can type where is Jeju Island located. What we expect is to find or to get the answer South Korea. But sometimes we just need to get one answer. We don't need to search or scan the documents. So if we do that on Google, Jeju Island here, we get the card. So this is the entity retrieval. So Google gave us the entity that we are looking for, and we get all the information we need. So this is it. Entity retrieval actually is a relatively a new field of research, but before that there was something called document retrieval, and it's what Google used to do before, which means instead of retrieving the entity, we retrieve documents and links to articles, like Wikipedia, for example. So document retrieval systems are relatively older than entity retrieval. So there are actually many models and methods in document retrieval. The research in entity retrieval is quite rich. So there are really many models like language model, BM25, and the fielded version of BM25, sequential dependence model, probabilistic retrieval models, and many others. So these models actually we are still using them for entity retrieval since they are already ready to be used. So entity retrieval actually takes advantages of the work that was done on document retrieval. Now we introduce generative adversarial networks. So the idea of generative adversarial networks is to unify the discriminative and generative approaches in machine learning. So we have basically two components. There's a generator and a discriminator. We have real data, which is the given data, and the generator and discriminator are playing what we call a mini game, a maximum minimum game. So the generator tries to generate fake data, and the discriminator tries to distinguish which data is real and which one is the fake one that the generator has generated. So this is the general idea of the generative adversarial networks. So the generator and discriminator keep playing the game until the generator actually succeeded at faking data that is exactly the same as the real data, and the discriminator can no longer distinguish between them. So in our entity search and retrieval scenario, the generator or the generative model generates fake answer entity for a given query. And the discriminator or discriminative model measures how relevant the answer is to our query. So this is what we are trying to do. So for each entity, for each query, the generator generates a fake answer, and then the discriminator sees that it's fake, and then the generator tries again until the discriminator actually approves the answer and accepts that it's the answer for the document. So in generative adversarial networks were first introduced in computer vision and image processing, but there was a first application in information retrieval, and it was called IR, GANs, which refers to information retrieval generative adversarial networks. So this application was uh, applied to question answering and recommendation systems, and it actually was powerful and scored quite good performances. So this actually was introduced as something called re-ranking model. We will talk about it in a while. So IRGAN is basically an adaptation of generative adversarial networks to the information retrieval. So what happens is that the D, which is the discriminator, and G, which is the generator, play a minimax game where D tries to maximize a function while the generator tries to minimize it. So we define the objective as minimax game. So, and we have the f function, which we define like this. So it is related, it's a function of the d, x here is the uh, data, and z is the prior, which is the noise data that the generator uses to make fake data. But actually, the GANs use the GS, the Jensen-Shannon divergence, but it has some problems. It leads to mode collapse and convergence difficulties. So that's why there is a new version of GAN. It is called WGAN, and it refers to Wasserstein GANs, and it uses the Wasserstein distance instead of GS divergence. So for example, here in the entity search and retrieval scenario, we have, for example, a candidate entities for a query. We have a list of entities, so we actually measure the distance between each entity and the actual entity of the query, and then we see how far it is from the actual query, the real answer, sorry. So WGAN is a new model, and it wasn't applied into information retrieval tasks until now. So here we redefine the f function for the WGANs like this. So we have the probability of the real data and probability of generated data, which is the fake data. And the f here is a continuous function, and it's parameterized by the weights. For our data, it is called DPpedia entity, and it's a benchmark in entity retrieval. It was built from combining queries from well-known campaigns, and it was linked to the results from the DPpedia knowledge base. So as you see, now entity retrieval is being more discovered, and more research is being done on entity research thanks to the availability of knowledge bases such as DPpedia. So DPpedia has two versions. There's a version 1 and version 2. In our experiments, we use version 2, which is the newest. So in DPpedia entity version 2, there are 4 types of queries. The SEM search query, it is a simple entity, simple word entity. And the list search is when we it's a list of entities. Actually, the answer of the query needs to be a list. And NXLD is a keywords like instruments, for example, music, and qual is related to questions. So each query in qual is a question and needs an answer. And for our entity, we represent the entity in 5 fields. There's a name, category, attributes, related entities, and similar entities. So this is a screenshot from DPpedia knowledge base for the entity Barack Obama, and we can clearly see that there are fields, and here we have the related entity to this entity. First thing to do in our experiments is to build an index and a primary retrieval system. So first we build an index of all entities with their 5 fields, and we add one more field that combines all the 5 fields and all the information about entities. It's just a text like an article. Then we use document retrieval models, which we saw earlier, to extract primary answers, which means a list of candidate entities from this index. And then we re-rank the list of entities using GANs models. So re-ranking refers to do a ranking again of the results we got from the document retrieving models. And LTR models are actually powerful than document retrieval models since we do a second phase of re-ranking. And there are many LTR models, and the most famous ones are LambdaMark and SVMrank. So here we refer to letter format is a file that is used for re-ranking models like LambdaRank and the GANs also. So we would use that for GANs. Our whole process can be defined like this. We have entities, we have queries and relevance, we build the index, then we do retrieval using document retrieval models. Then we filter and build the leader files. Then we run the learning to rank models, IRGAN and WGAN, and we get final results. So for this experiment, we use PyTorch to build GANs and WGAN model. We use Galago Search Kit to build the index, and RankLab for learning to rank models. And of course, we use data from the DPpedia knowledge base. So for results, here are results of the document retrieval models. We have 6 results, which we combine into the later file, and we use that file to run learning to rank models and GAN models too. We do another study for each search. We measure how good our models are for each type of query. We have the sim search, the list search, the called, and the NXLD. So we can see that IRGAN and WGAN perform quite good compared to the to the document retrieval models and the learning to rank models. Thank you. This is the end of my presentation. Thank you for your attention.
Okay. Thank you very much for your presentation. We appreciate your participations to the conference. I'd like to invite the guests who are attending to this conference to ask questions to you. Anyone?
Any question?
Any?
Hello, good morning.
Good morning, sir.
Good morning.
So I am Dr. Samresh Misram from Bhubaneswar, India. So how can you ensure that your model is better? Have you compared with other models, such type of models?
Okay, so what we do is we have metrics. So we have 2 metrics for measuring the performance of our models. We have the map and the NDCG. So we measure both metrics, and we show the results. The first one for map and the second one for the NDCG. That's how we compare the models.
Anyone has any question? Okay, then let me ask some question to you. So how you build your index? Can you explain? You need
Right.
to build your index.
So for index, we use a toolkit which is called Galago Search Engine.
Okay.
What we do in the index is we get each query, each entity, and we relate the entity. It's like a big vector that has the entity name. If you remember, there's an entity name, entity category, attributes, related entities, similar entities, and we add one more field that is a combination of all the information. So it's like a table, for example, and each line is one entity with its representations.
All right. Another question, why you need to feed the noise generator to build your model? Can you go, I think in the third slide maybe. Yes.
Here,
Yeah.
here we
What's
need
the
a prior, right? We need a prior probability. So if the generator wants to, for example, generate a data, it needs a prior, something, a base from which it can generate. So this is called a noise. It's just a random vector that we feed into the generator. So it can be arranged, and at the end it generates some kind of data that it is supposed to be similar to the real data here. So noise is just a prior.
I see. Okay, thank you very much. That's two questions I have to ask. Anyone wants to ask any questions? All right, if that no one have any question, thank you.
Thank
for
you.
Nice, yeah, okay. Now we'll move for the next presenter. Okay. Our next So we have still 2 minutes left. Our next presenter is topics is a comparative analysis of data mining analytics tools. We'll wait for him. Once he is here, then we can. All right. Now I'd like to invite presenter 47. If you are there, let me know so I can switch to host your presentation. Okay, we are waiting for 2 minutes for presenter 47. If he is not here, then we'll move to presenter 32 to present his presenter talks. Get ready, 32, if 47 is not here. May I invite presenter 32 to present his paper? Are you ready? Presenter 32.
Yes.
Okay. Go ahead for your presentation. I have just switched to you as a co-host. You can now share your screen also.
Okay. Sorry, but I can share
Yeah, your
my
screen is shared now. You
presentation.
can just run your screen, I think. Play
Oh,
slideshow. Just you can. Yeah, it's okay.
oh,
Go
is it
ahead.
working?
Yeah, it's working.
Okay. Hello, I'm Sang-hoon Kang from Buyong National University in Busan. And today I will present about the classification of multiple steganographic algorithms using the hierarchical convolution neural networks. So my content will follow with the introduction, with brief concept of steganography and steganalysis and the hierarchical structure for using this paper and my result and some conclusions. So the steganography is a data hiding techniques in digital media like video, audio, and image. So the main concept of the steganography is data hiding data in the multimedia with completely looks innocent. So if, except the sender and receiver, no one can see the there's a data or not. So like this one, we have the images and we have the data, but other people can see the data is embedded or not. So we call the original image as a cover image, and we call the stego image as a data is embedded image. So we embed the secret data into the cover image, then we can get the stego image. But the cover image and the stego image looks completely same for human eyes. So then how can the steganography embed the secret data is by modifying pixels value. So the image is a array of pixels. So we can embed the secret data with the bitwise modification of pixel value. So we change the pixel values so we can embed the data. So the receiver can extract the secret data with the stego images and which algorithm of steganography is used and the size of secret data. He can get the secret image, secret data, sorry. So the steganalysis is the opposite of the steganography. So we want to detect the stego images communication. So it's opposite side of the receiver and sender. So in here, now we are here, then we want to classify the images. Suspicious image is a stego image. So if we find the stego images, we can tackle them. So then the steganalysis, how can steganalysis detect the stego image is using the statistical difference between cover and stego images. So the graph below means that the neighboring pixels difference between cover images and stable images. The blue line means cover image, and the orange dotted line means that LSB images, which means the one steganographic algorithm. As you can see, the tiny difference area has bigger difference between cover images distribution and stable image distribution. So by using this statistical difference, we can detect the stable images from the cover images. So in stack analysis method, there's two mainstream. One is the handicrafting method, which man-made feature extraction process, and the other one is the CNN-based structures. So in early age of stack analysis method, we use the feature extraction method. After the AlexNet in 2020, the tries to adapt in the stack analysis into deep learning method is, so we use the CNN-based method. So in here, we don't need to extract any features, but the CNN structure can extract automatically the cover and difference, cover and stable differences. So because we it's a long years after that AlexNet, the many classification method is introduced, and the ResNet based method in 2016, the stack analysis method, which classify the cover image and stable image, achieve over 95% of accuracy. So this is the ResNet concept. It's not just adding the input value into output values. So I think the binary classification of stack analysis is just fully saturated. So we need to try some other things. So then we can think what's the next. So I've been trying to classify the steganography algorithms. I think the extracting and classifying the steganographic algorithm is the first step for extracting the security data from stable images. Then the first thing we should know is which stable algorithm is used. So I've been trying to classify 4 steganographic algorithms. That there are LSB, PVD, WOW, and Junior. So if these 4 algorithm is commonly used the steganography algorithm, so I'm trying to classify these 4 algorithms and also have cover image. So I need to classify for all 5 classes. So before explain about my experiment, so I just told the details of my experiment. So in steganography, we use the 256 by 256 grayscale images, and we use the 13,000 for training and 10,000 for testing. So I need to try classify the multiple stable images. So I use the 30,000 for cover image and 7,500 for each stable classes. So, and I trained my structure with fixed training count with 200,000 for iterations and use 60 batch size on PyTorch library. So classifying multiple steganography algorithms have some problems. One problem is the high similarity between each classes. So the cover and stable images have quite large difference between of them relatively, but the stego images and the other stego images has relatively low difference from between each classes. So to where classifying these algorithms, so we need to catch the tiny difference for each classes. And the other problem is the lack of single convolution neural networks capacity. So it's the same as the first problem because their difference between each class is too small. So with multiple classes, we can classify the stego algorithms very well. So we need to change another method. So this is our base model. I just based on the XUS network, which the steganography binary classification method. So in this model, there's a we have the 256 images as an input, and in stag analysis method, we use the high pass filter for pre-processing our input images, enlarge the stego noises and suppress the contents of images, and several convolution layers. We get the 5 classes probabilities. So the first method I trying is just enlarge my output to 2 to 5. So cover and stego to cover and LSB, PVD, wow, and universe. But in that experiment, I get this result. The first table means that each classes, each steganography algorithms binary classification result. So as you can see, there have except the universe and wow, they have quite higher accuracy. But in the quinary classification, this PVD steganography algorithm has we can classify at all. But in the binary classification, we have 90.8%. So just enlarging the output of steganographic classification problem is not sufficient for our purpose. So I changed some structure to the hierarchical models. So it's I used the multiple convolution neural network structure for classify algorithms. So in the network 1, we classify the cover and stego. Stego means that every other steganographic algorithm is included. And network 2, I classify the district of the steganography algorithms. One have the LSB and PVD, and the other one has wow and universe. And the rest network, with network 3 and network 4, classify the each algorithm. So this table means that each network's classification accuracy. So so network 1 has about 82%, and network 4 has 68% of accuracy. So this table means that these hierarchical structures result, as you can see, we have the 72% of average accuracy. Before the former result, the PVD steganography algorithm is not classified at all, but with the hierarchical models, we can classify the 5 classes. So we get the 15% of increase of average accuracy. So but we have one more problem in the accuracy of network 4. So you can see the network 4 have average 68% of the accuracy. So it's a quite low performance. So this caused because the WOW and S universe steganography has similar embedding scheme. So, and I think our base model structure is too weak to classify these similar algorithms. So we adopt the ResNet-based method like this one. So for the former comparison, so we didn't change a lot of our structure from the base model. So we just add the ResNet block, which means that using the ResNet-based method. So the ResNet-based method can preserve the gradient vanishing problem for each layer by using the simple idea, which the adding the input to the output. So compare with our base model.
Let me interrupt you.
One.
You have 1 minute, please. You need to finish.
Okay. So we just add the ResNet-based method, and we can get this result. So as you can see, the total accuracy is quite higher, and this one means that our ResNet-based method, we just changed the network for, and we can get 8% of increase of accuracy. So we have the 34 depths of the convolution network. So this is my conclusion. And so for classifying multiple steganography algorithm, so the single structure is not enough for classifying the multi classes. And so we need to go reinforcement our structure, but because we use the ResNet, but it's just a base model and it's not fully refined. So I need to refine our ResNet-based structure. Yeah, that's all for my presentation.
Thank you very much. I would invite the audience to ask some question. If you have any question, please go ahead. Anyone has any question? Okay, so let me ask one question for you. So you achieved 8% higher accuracy than the previous work. That's good. Yeah. Then what's the complexity in terms of resources you need more to achieve this kind of accuracy? Do you need any others? Like I'm talking about in terms of memory or CPU utilizations. That did you compare with other algorithm or algorithm, how much it's consumed?
So our first model is just with 5 convolution layers. So it just relatively have low memories for using our GPU. But compare with that, the ResNet-based method actually use much higher memories. But the cost compared with the 2 networks, this plain method, but this ResNet-based method has higher performance rising compare the trade-off between the memories. So in the deeper method, we can use higher batch size, but unless we reduce the batch size, but we can get the higher accuracy.
Okay.
So
all right. Thank you. We are running out of the time. Thank you for your participation. I appreciate you for your time. You allocate for us.
Yes, thank you.
Okay. Thank you very much. Now we are going to move for the next presentation. We have presenter 7. I hope you got ready.
Okay,
So
thank
let
you.
me make you host. Okay. You can now share your screen, I think.
Okay.
7. Yeah. Yes.
Okay, thank you, doctor, for the time. So I'll share my screen first. Right. Okay, can you see my slide?
Yes.
Okay, thank you so much. So thank you for the time. So good morning, everyone. So I'm Arbi from Informatics Engineering, Universitas Islam Riau, Indonesia. So today I would like to present my research about and entitled towards a sentiment analyzer for low resource languages. So here, this is the overview of what I'm going to present today. So I'll talk about the background, a little bit of background, and then my research goal, some literature studies, and my research approach and results, and also the conclusions, the last one. So starting with the background, the sentiment analysis or opinion mining is a part of text mining. So everyone know that we can basically analyze some text, and it is basically a computational research that analyzes the textual expressions from opinion. And then the other thing that we can analyze is like the sentiment or the emotions from what we can get from the text itself. So usually the data is retrieved from social media and also from other media. And a rich sentiment analysis corpus is very crucial in creating a good sentiment analyzer. So, but the problem is for the low resource languages, it has inadequate language resources for computational linguistics. So what I'm saying about the low resource languages is like, for example, in Indonesian ethnic languages, we have like 700 ethnic languages in Indonesia, but we have small data on the or corpus on the Twitter, for example, that people speak in their ethnic languages. So for that kind of languages, low resource languages, it will be very difficult for us to do a sentiment analyzer. So that's the problem for this research. The small corpus for low resource languages hinders the development of a good sentiment analyzer. So even though that what I'm trying to target is the Indonesian ethnic languages, but because of the difficulty to find the data of the ethnic languages in Twitter, so for this research, I'm using Indonesian text as a data training to analyze this. So my research goal is to identify which classifier is more suitable to be used in creating the sentiment analyzer for low resource languages with small corpus. So I've been studying several previous popular classifiers. So the first one is the naive-based classifier method. So the previous research used this classifier to investigate the sentiment analysis of the Twitter users on the traffic jam in Bandung, which is the West Java in Indonesia. It shows 72% accuracy for a small sample, which is only 100 records, and 93% accuracy for a bigger data, 13,000 records. So of course, with a bigger data, the accuracy could be higher. And the other research using doing data classifications using k-nearest neighbors and naive Bayes, which the corpus downloaded from the T-REC legal track. They shows the optimum value for the k is 13, and the accuracy is, in average reach 55% only, but still better than using naive Bayes, which is only 39%. So the other research is doing the hotel rating through reviews using decision tree classifiers, and then they shows that the rule set can be easily generated, and by analyzing each level of the tree, a particular surface quality can be improved. And the last one is multi-layer perceptron, which is like one of the types of the neural network. It has a 5.9% better accuracy than the clinical accuracy by the dermatologist for detection of malignant melanoma in that research. So, of course, there are lots of other methods that being used for analyzing the sentiment of some text. But in these studies, I only focus on these 4 methods that shows a good result for small data. So next to my research approach, the data sets used here is Indonesian tweets crawled using RabbitMiner with a query hashtag KPU Jangan Curang. So actually, we were trying to find the tweets in Indonesian ethnic languages, but since the data is very low, so we just try to use Indonesian tweets in this case. So the evaluation measure is the accuracy, and then we will compare the 4 classifiers with small data. In this case, only 200 tweets. So we want to show that in which methods, which classifiers between naive Bayes, k-nearest neighbor, decision tree, and multi-layer perceptrons will work well on the 200 tweets, and also with some different 11 experiments that we use that we conducted with different size of training and testing data split to show from the smallest data to the higher number of data, which is in this case is 200 tweets. So the steps that we use is the same as the other research. First, we do the data crawling. We aggregate the data from Twitter with the hashtag KPU Jangan Curang using RabbitMiner, which are used as a training set and testing data sets later. And then we pre-process the data. It's a process of cleaning the data by deleting common words, by referring to stop words. In this case, we use the existing Indonesian stop words. And the clean data will be weighted using the term frequency inverse document frequency, TF-IDF. And after that, we'll send this clean data to 4 different classifiers. The 4 methods are applied to classify the sentiment into positive and negative sentiments. And then lastly, we evaluate each classifier's accuracy, and the result will be evaluated with manually labeling the classifications. So the clean data is labeled manually, and then we will see the result, we compare the result with the classifier. And then the accuracy of the classification will determine whether a new training data set needed to be added or not to reach the accuracy threshold of 80%. So here we set the threshold of 80%. And then here's the result. So we can see that this is a training data size, which the different split training and testing data size, from 25% to 75% of training data size. And then we compare the 4 classifiers, which it shows that the naive-based classifier, which is the red one, and also the MLP multi-layer perceptron classifier, which is the green one, outperform the other classifier, which is k-neighbor classifier and decision tree classifiers. So in conclusions, every classifier shows a trend of increased accuracy on larger size of training data, which is obvious. But we found out that the decision tree classifier shows a very low performance on small data, while the k-nearest neighbor classifiers show accuracy below 76% on all combination size of training testing data split. And both naive Bayes and multi-layer perceptron classifiers have the highest accuracy on all combination size of training testing data split, and show consistent increase of accuracy as the training data size increase. So the 2 classifiers are potential to be used in creating sentiment analyzer for low resource languages with small corpus. So for our next experiments, we'll try to focus on these two classifiers, or maybe using the multi-layer perceptron, because it shows a better result than the naive Bayes. And we can continue to find more data on the Indonesian ethnic language data, and using also RapidMiner, and then to extract the data from the Twitter. So for that experiments, we will use like 10 of we plan on 10 Indonesian ethnic languages, and we try to use the multi-layer perceptron and naive Bayes also to see whether with the small and larger size, it will be best fit for the low resource languages. So that's all for my presentation. Thank you very much for your attention.
Okay, thank you very much. So it's now time for question and answer. Anyone has question? Yes. Please.
Hello.
Anyone from the, yes, please.
Thank you for your presentation. I have a question about your data. So you said you're trying to do to build your sentiment analyzer for the ethnic languages in Indonesia, right?
Yes.
And then you say that because you don't have enough data, so you will use the Indonesian language instead. Yeah. So did you do some kind of transfer learning from Indonesian data to the ethnic language, or did you do your whole experiment in the just the Indonesian language? Thank you.
Okay, thank you so much. So because we have small data on the ethnic languages, so in this case, we want to see the pattern also. We want to see whether the same methods will work better on some ethnic languages and some other ethnic languages. So we are not going to do kind of transfer learning from Indonesian data. So we will have several distinct experiments between for each different ethnic languages, and we will see. We want to find the pattern on each of the ethnic languages, because some ethnic languages they use like more abbreviations than the other ethnic languages. We want to see the pattern first, and then we want to find a better method to solve every single ethnic languages in the future.
Okay, thank you. I also have another question about your data. So your data is basically from Twitter. Do you think, or did you think about getting your data from other collections instead of just Twitter? Do you have any another resource for your data for the ethnic language in other resources or other platforms?
Okay, thank you so much. And this is a very challenging task for us to find more data on ethnic languages, because we can find some ethnic languages data from Wikipedia, for example, but we can only find less than 10 Indonesian ethnic languages which has data in Wikipedia, for example. So very small corpus on ethnic languages, and also it's also challenging to find the ethnic languages in the Twitter also, because most of Indonesian people they use Indonesian language while communicating in Twitter. So it's also a challenging task for us to find lots of tweets in ethnic languages, and it's also challenging to classify, to differentiate whether this is a Indonesian ethnic language or just Indonesian language, because sometimes they also do a code switching. They mix Indonesian language and ethnic language. So it's a very challenging task that for us to try to find the data.
Thank you for your answer.
Thank you very much.
Anyone on that has any question? Actually, I had also same question that you collected from the Twitter. My interest to know which platform is very popular in your country, Twitter or Facebook? How about Facebook? Why you didn't collect from Facebook?
Yeah, so Facebook is popular in the past 10 years in Indonesia. So nowadays, less youngster use Facebook. So only old people use Facebook in Indonesia. So a lot of youngster who speak in their ethnic language usually use other social media like Instagram or Twitters. So Indonesian also one of the biggest Twitter user in the world. So we can get lots of data from Twitter rather than Facebook.
Okay.
So why have used?
Please, sir, go ahead.
Hello.
Yes.
So why have used 200 tweets? I mean, it can be increased also.
Yes, of course. We want to show what for small data which methods work best. So when we see the pattern that multi-layer perception and naive-based classifiers works well on 200 data. So in the future we can increase the data to 1,000, 10,000 and bigger data. But what we want to establish now is the baseline for the low resource data, which method works best.
Because sometimes the trends also increase in terms of 10,000, 15,000, or sometimes
Yes.
on nearest to 1 lakh. Fine.
Yes. Yeah. So of course, in the future experiments, we will use a pretty large range of the data sets using the NFBs and MLP classifiers. But because this is the earlier stage, we just want to find out the best method, and then in the next experiment we will use more data and bigger size of the training data to experiment on those two classifiers.
Okay, thank you.
Okay, thank you. I have last question. Lots of questions for you. The question is that you compare only the accuracy, right?
Yes.
And the two algorithms like naive-Bayes and MLPC classifier almost similar looks like. So how about the other parameter to compare, like resource utilization, cost, trade-off between these? So you can know better. You just accuracy is just reflecting which one is accuracy. But in the other way, we have to trade off between the cost. So so what is your plan about to compare this kind of results?
Yeah, that's also a good parameter that we can add later on. So the cost of utilizing data, the cost of retrieving the data will be depending on the source of tools that we use to get the data. For example, in this case, we get the data from the tweeters just using the rapid miner. But in the future, we can extract data from corpus like Wikipedia article and all of that. But still, once we get the data and we pre-process the data, and everything will work in any different in any classifiers. I mean, so at that stage, when the data is ready to be processed with the classifiers, it will be the same. I mean, either we use MLP classifiers or naive-based classifiers, it will not affect the cost of obtaining the data, because that is the earliest stage of the pre-processing and obtaining the data. So, but the parameter on the classifier itself, in this case, in this experiment, we only focus on the accuracy, but in the future, we might try to find the other measure to differentiate the performance between the classifiers. So thank you, Doctor. We will try to find the other parameters for the obtaining the data and pre-processing data in the future.
Thank you very much for your.
Thank you, Doctor.
It looks very promising. Thank you very much.
Thank you.
All right, now I would like to invite presenter 25. If I don't know whether he is available. 25.
I'll stop sharing.
So our next presenter is 25. His topic is satellite image, segmentation and classification using fuzzy C-mean clustering and support vector machines. So we are going to wait for him. Actually, his session was 11:20, so we finish early. So let's wait and see whether he will be available or not. Okay. I hope he's not here. Once he will come, then we'll start we'll move his session next. Now I'm going to present. I have one paper, so I'll ask Dr. Samresh Mishra to work as a chair now. Okay, sir, please
Thank you.
invite me to present my works.
Okay, so Dr. Mohammad Azam Hussain.
Yes, sir.
So your paper is development of an information
No,
system.
I have actually 45. Sorry, sir. 43.
45, okay.
He apologized for coming today. So I already have a message.
Okay.
53 will be
Okay.
not here. So let's
So-
move on. 45. Yeah.
So let's move to 45. That is exploring the volatility of large scale shared distributed computing resources.
Yes, sir.
So you are the single author, sir?
I have other authors also,
Okay.
co-authors.
Okay, so let us start this one.
Okay. Okay. Good morning, everyone. I am Dr. M.D. Azam Hussain. Today, I'm going to present about exploring the volatility of large-scale distributed computing resources. This work is be done with the help of KISTI, Korea Institute of Science and Technology, and the National Institute of Supercomputing and Networking Centers. Okay, I'm working in Kyongdong University as the assistant professor in the computer engineering department. So before going to my content, let me talk about something, the overview. As you know, the large scale distributed computing, one of these, the very popular is the grid computing platform, support with tens of thousands of resources for scientific applications from multiple administrative domains, and where the users can schedule their task on that shared resources. But the problem is that since the shared resources are from the different institution and they are administered by autonomously, it is very difficult to find the information that where, how much resources are available, so that as a user, I can schedule my task on the particular site. So it is very difficult. There is one information service in the grid it suffers providing the dynamic informations accurately across the autonomous boundary, because every institutions are autonomously, they manage their resources, so it's difficult to get the information across the boundaries. And another important thing is that these shared resources are mostly unreliable, unpredictable, and heterogeneous. We don't know which resources are available. So the key question is how a user can know which sites, that is another term is called computing elements, are available to provide the free resources. This is the key questions. How can we know where is the available resources there? If some site has a resource, what is their performance? How much resources are there? This is the very key questions that can help the users to schedule his or her task on the agreed resources. So in this paper, we make a volatility study of shared resources to discover the dynamics behavior of a computing sites or the resource provider sites. Okay, so this is the main overview. So the topics that I'm going to talk today, first I'll briefly discuss the motivation, then I highlight some challenges relating to the grid informations, then our contribution, and then we will talk about our scout system that built to get this kind of information, and I share my experimental results, and finally I conclude my presentation with some conclusions. So as you know, high throughput computing or many task computing application requires huge resources, because this type of applications compose of tens of thousands of loosely coupled tasks and often require huge computing power. And the task execution varied from milliseconds to hours. Some tasks need millisecond to 1 hour. Okay, so leveraging the grid computing resource is important. Okay, so collectively it can support around the almost petaflops level computing powers, and and it is one of the powerful test bed because it has a huge capacity at almost zero cost. The participation organization can share their resources. So before in our 2015, we built a system that is called the STC CAS that can automatically use to schedule the task in the different platform, like different kind of application, like new drug discovery, high energy physics, and body problems. So there is a lots of MTC applications are there today. So you build a system that can use the grid computing resources and launch their tasks there. But the problem that we face, that's we don't know how much resources are there. These are motivated us to build another new system that we can incorporate with this STC CAS. So we build the Scout. I'm going to talk about the Scout in the later slides. So another motivation is there's a virtual organization. We call what is virtual organization is that it's a set of individual or institution. They come and share, they control and access the resources. And this aggregated approach can coordinate research multiple sites for solving large scale problems. And usually these resources are heterogeneous in physical resources, and we can combine and think as a single virtual resources. And a virtual organization consists a number of computing elements and storage elements. Computing elements provide the capability, which is a collection of worker nodes or clusters, we can say. Okay, so this paper, this works, we actually want to know the computing elements behavior and their resources. Okay, so the user may be a member of one virtual organization or maybe more virtual organizations same times. So user can launch his application using the STC CAS by using the information from the Scout, which virtual organization where he has available resources, free resources, computing resources, so that he can schedule his task accordingly. All right. So So as I told you that the problem and the challenges with this system is that grid system is like, it has large scale distributed platform. It's composed hundreds of geographically distributed machines. And the resource are dynamically available because some owner may leave and join in unpredictable fashion. Resource may be unavailable due to some hardware or software maintenance, or maybe some failure. Sometimes maybe network error. This kind of the challenges are there. Sometimes resource ownership and sharing are administrated by the local autonomous bodies. So everyone has different rules and policies for sharing. Like someone wants to give more priority for their local resources rather than local users rather than the outsides. So this kind of things is very challenging to get out very good information systems that can provide user a clear pictures where the resources are available and which one is the more okay. And the last one is the some resources are dedicated for local policy due to the local policy, as I said before. And as I told, the GIS, the grid information system, is unreliable. Why I'm talking unreliable? Because as you can see, when we query about the information system, we'll get this kind of random information. Like this is the CE names, as you can see in the right side, computing elements name. And it is showing some information about the number of CPU, how many free, number of jobs are currently submitted and running, and how many jobs are waiting. This kind of information are provided. This information is not exactly dynamic and real. It is some statisticals, and these results sometimes doesn't reflect the real scenarios. So we can say that we show that above information is not correct and even not useful. If we use this, we will show in our experiment result, this information is not useful. So it suffers. Why GI suffers? Because diverse source of data, interoperability, different institute have different data format, and interoperability is also issues among the different institutions. And all the resources are dynamically changing. They are so it's very difficult. And there is each autonomous site, they have their own information system. So combining all of this information system is really challenging one. Okay, so we need some solution that we can somehow get overall in our virtual organization, that where the available resources are there and their response performance is much better, so that user can really launch his task and can get better results. Okay, so to do this in these papers, actually we are going to find some shortcoming, that is to overcome the shortcomings of grid information system by identifying and then understand the dynamic CE behaviors, studied the availability and capacity of each CEs, which CE has number of free resources and what is their performance, and evaluating our effectiveness on real grid environment. So we launch our some applications, micro benchmark application on real grid environment, and we found that if we know the prior to the resources, it perform much better. So before to get this kind of information, we build a scout system that's periodically profile the grid computing based on available number of CPU, average response time, and monitor the performance CE of the virtual organizations. And we have developed using the Delight grid middleware. Scout system can submit group of scout, each computing node, and multiple virtual organization at the same times. So what is a scout? Is a grid job, just these small jobs we just submit, and we want to see the response, whether that job are accepted by the CEs or not. If these CEs are accepted, then we can assume that CE has enough CPU available to accept the jobs. So this is the architecture. You can get this overall architecture of our systems. We have, so I don't want to discuss details. We already have a paper on this. So we have some scout report manager. Scout manager actually submit the results, and we have the queues. From this queue, emitter is responsible to submit the scouts to the different virtual organizations. And this virtual response, and we store this data, excuse me, on the database, and then we can analyze the volatility of the different resources of the different computing elements. So I'm going to just, so as you can see, let me go from the beginning. Scout are submitted and it goes and it waits into the queue. And the emitter is responsible to submit the scout to the virtual organizations. Once the scout are accepted by some virtual organization, it sends the reports to the scout report manager, and then report manager stores this report onto the database about the resources. In this way, our scout system briefly works. Okay, so to do our experiment, we use on two real grid virtual organization. One is the France Asia virtual organization. It is between the France, Asia, like Korea, Japan, and China. And we have a biomed virtual organizations, large scale international and multidisciplinary. It's from France, Germany, Italy, Netherlands, Poland, and Russia. These view are supporting many different sites of computing elements, and it has tens of thousands of CPU cores for its users. All right. So after analyzing the some volatility of the biomed virtual organization, we can see that each day in this biomed there is different number of computing elements are available. As you can see in the day for 12 to 15, the number of available CEs is less than around 20. It's hovering around 20, and then again it increases. It is maybe due to some maintenance or some other purpose. And then we also studied that some resources, some CEs are constantly free. That means they are providing higher number of resources, like CE1. You can see almost every day it has around 200 CPUs. On the other hand, CE3 has a very fluctuation in terms of their resources. Some days they are available, some days they are not available. So from that perspective, we can understand what is going on. And the CE3 is always constant. It has around 40 CE. So from this, we can see that different CE has a computing element has a different number of available resources. Okay, and each day, each virtual organization have a different number of CEs are available. So by knowing this kind of information, user can easily exploit this information to launch his task or application on the grid platforms. Next one, we also see the performance in terms of the number of cores. This is this horizontal line is talk about the CEID. This means each are the different CE, and we can see that different CE has a different number of CPU cores are available, and has a different response time. Even some like ID7 has a much higher number of available resources, but his response time is very high because maybe it's due to the network from my side. Okay, even you have some resources or the delay of the queue, it could be the problem. It could be that why it may be the response time is higher. And even some has a very small amount of resources available, but still their response time is much better than the others. So it could be so from this study, we can know that exactly which CPU, which computing elements is better for my purpose. Okay. So in order to experiment our micro benchmark, we make 4 set of virtual organization. In each set consists 10 VEs. Volatility studied top Cs based on number of free cores. Those have a higher number of free cores, and we label is profile top 10 C. And then we also make another one, volatility study top 10 C based on response time, which response time is less. And then we use the grid information service that provide us by the grid information system. So we also take the top 10 Cs based on the grid information service. And then we also select randomly 10 Cs, randomly, any 10 Cs randomly. So on these 4 sets Cs, we launch our tasks, our micro benchmark task. So these are the top 10 C based on our experiment, the study of our data, number of available core, average number, and their average response time. These are the 10 Cs. And these are the 10 Cs of the grid. This information are provided by the GIS. So we select the top 10 from there, and then we select the randomly 10 GIs. And we have evaluated on the micro benchmark simulation using short bed of task. It is sleep task, fast 5-second task. So once the task will be the sleep task, we submitted. And we provide different number of tasks, 250 to 5,000 tasks we submitted, and we compare the results.
So 1 minute to complete.
Thank you, sir. So as you can see, success rate of the studied volatility study series is much higher compared to the other two. And random series is providing very low results because randomly we selected, we don't know which one has actually resources. And the next one is that we also find the mark spans, define the total number of required to process the entire set of tasks. As you can see, the random C is perform much worse than compared to the grid information. Both are performing very high. Their mark span is very high compared to the studied top 10 Cs. And you can see that those has a response time is less. That Cs are providing much lower performance, and completion time is much lower. Okay. So in conclusion, that grid computing elements having varying, has a different capacity as we see, and it has unreliable performance. Grid information service suffers from providing the exact dynamic informations. So we need to study the which CEs has a different, how much resources they have available. If we user know, if a user know where free resources are available, it will increase the system throughput by reducing the response time, and also increase the improve the job completion rates. So in futures, we are planning to apply some AI or ML tools on collected data by Scout systems to predict the best resources. This is my works. Thank you very much. If you have any question.
Thank you for a very nice presentation. So now it is open for all to put questions. Anyone would like to put any question? Okay, now I have a question.
Yes, sir.
What do we know that the distributed, if you take the case of distributed database management system, fine. So in that case also, we assume that it is a collection of databases stored on multiple computers over a large geographical area.
Yes, sir.
But it looks like a single database. Fine. So we can imagine that the site, they are also managing or processing the data using the parallel database system. Clear? So now in a distributed query processing, fine. So have you analyzed the distributed query processing, because you do not know where the data resides? Fine. The sites where the data resides, at that site only the processing can take place. So have you ever analyzed that distributed query processing in your, the research area?
Okay. Thank you, sir. You are asking about the storage related questions. Actually, we just in our work we just focused on the computing resources, like how many CPU cores are there and what is their response time. And your question was very this question was everyone is asking that we are going to use to know about the database status, that different database may have different site have different performance. You're exactly right. So in futures we have a plan to work on the storage area. Now we are working, this work was mainly focused on the computing area. Thank you, sir.
Thank you very much.
Okay.
So now we can move to the next paper.
Yes, please, sir. You can host, you can chair on the next paper also, please. It's 25, I think, sir.
This is 25, yes. Satellite image segmentation and classification.
Very fine. Good morning to one and all.
Morning. Good morning. Yes. Paper ID 25.
Yes, sir.
You can share now.
Okay. Huh. Good morning, Dr. Prashant Kumar Patnaik.
Is my screen visible, sir?
Yes, it is visible. Go ahead.
Yes, sir. My title is Satellite Image Segmentation and Classification using Fuzzy C-means clustering and Support Vector Machine Classifier. First, introduction. Application of satellite image. It is used for weather prediction,
Please,
monitor global
dear
environment.
author, please introduce yourself.
Sir, myself Manjula, Assistant Professor, SRM University, Sonipat, India. Then Ojas Vitamuyal, she is a MTech student from VIT University, Vellore. Then Ahmad A. Al-Absi, he is the Dean of International Faculty. Then Director of Global Academic Collaboration Center, Hyundai University, Global Campus, South Korea. Sir.
Okay. Thank you.
Then
Please continue.
yes, sir. Introduction. Application of satellite image. It has been used for weather prediction and also it is used to monitor global environment conditions and geographical and geological applications. Advantages of satellite images. It is used to cover huge zones and also by using that image we can visit any part of the globe. The capacity to gather information unhindered by local air traffic. There are two types of satellite images, high resolution pictures and low resolution satellite pictures. High resolution pictures, it is used for transportation, organizes mapping, calamity readiness, urban arranging, exactness cultivation, and broadcast communication. Low resolution satellite pictures are used for some of the applications such as environmental assessment, local mapping, forestry management. Manual processing is not much able to retrieve some hidden treasure of information in the satellite image because human eyes are insensitive to focus on some of the hidden information such as color, texture and shape. So we are going for computer processing. This is the example of visible satellite image. This is the example of visible satellite image. Requirements of the application build. Hardware requirements are processor with core PC with core i3 processor, RAM 8 GB, hard circle 320 GB recommended. Software requirements, MATLAB. Objective. Our objective is to classify the satellite image into river images, forest images, residential area, desert images, and mountain image. So here we are using some of the algorithms such as fuzzy C-means algorithm, Gabor filter, GLCM, and support vector machine. And also we are using some of the modules, image segmentation, feature extraction, and classification algorithm. For image processing, we are using MATLAB. In our existing system, we are using texture-based image classification with GLCM-based feature extraction algorithm. So that work can be enhanced in the context of classification accuracy and feature extraction phase. So here we are going for efficient classification technique for the recognition of region in satellite images. In the proposed system, we are using Gabor filter and GLCM. For GLCM, both are used for extracting color and texture features. So if we are increasing the number of features and also we get the classification accuracy also increased. And also we are adding one module that is image segmentation. For image segmentation, we are using fuzzy C-means clustering technique. So the results are more optimized and take less time to extract feature than the previous work. Architectural design. Here we are using the image satellite image. From that image is used for classification. First stage is pre-processing. In the pre-processing, we are going for noise filtering to filter unnecessary information and remove some types of noises from the image. Then image segmentation, here we are applying fuzzy clustering means algorithm for segmenting the image into, for partition the image into multiple segments or clusters. Feature extraction, it is used to extract features by using GLCM and Gabber filter algorithm. Then image classification, classify the satellite image into multiple types by using SVM algorithm. Then images classified into 5 categories. So here we are giving the input database image into training phase. So in the training phase, we are having 3 phases: image pre-processing, image segmentation, feature extraction. After extracting the feature, that should be given to similarity measurement. Then it should be given for classification. It should be done by using SPM. So further classified into desert image, river image, forest image, residential image and mountain image. So there are 3 image classification stages: image segmentation. So digital images classified into multiple segments. Here we are using fuzzy C-means. Advantages of fuzzy C-means is fast and robust. Here data sets are gathered into n clusters. Then feature extraction. We are extracting most of the features from original data. So for that purpose, we are using GLCM and Gabber filter. So it defines structural and spatial properties of image, that is color and texture. And also we are inspecting texture by considering the relationship of pixels. So Gabber filter, it is used for various applications such as texture division, object recognition, fractal measurement administration, document evaluation, edge detection, retina identification, image coding and image portrait. Image classification. Image is classified by using SVM algorithm. It is used for training and testing framework. And also we are extracting color and texture feature from the image. That features are given to next stage of classification. So considering these components, color and texture, by using SVM, we'll group the satellite picture into 5 various classes. So image processing toolbox, it includes image processing, analysis and algorithm development. For image filtering and enhancement, we are using for contrast adjustment and deblurring. Then texture analysis, pixel and image statistics. Then filter, segment and perform other image processing operations on 3D volumetric data. Then run image processing code and graphic processing toolbox. Then result and discussion. Here we are taking 100 satellite images. From that 50 images are used for testing purposes, then 50 images are used for training purpose. It is implemented by using MATLAB Simulink 2016A. Here performance metrics are precision, recall and accuracy. Precision equal to number of relevant classified images divided by total number of classified images. Recall equal to number of relevant classified images divided by total number of images in collection. Here number of queried images, first we are taking 10 images. In the 10 images, the recall is 1, precision is 1, recall is 0.15. So if you are increasing the queried images, precision is reduced, recall is increased. So this is the evaluation of performance of proposed framework based on precision and recall. So here we are seeing the classification accuracy for our proposed technique. This is existing technique. In the proposed technique, so we are taking 100 query images. For that we are getting the accuracy as 99.6%. In the existing system, the queried images we are taking the same 100, but the classification accuracy is 99.4%. So our proposed algorithm performs better than existing algorithm. This is the output for our project. First, there are 5 modules: input image, pre-processing, segmentation, feature extraction and classification. This is the classification result. First, we need to give the input image for pre-processing. Then we are segmenting the image into multiple segments. used to identify contextual and non-contextual areas from the satellite image. Then next phase is feature extraction. We are extracting texture and color from the segmented image. After feature extraction done, we are going for classification algorithm. We are using SPM for classification. After classification, it gives this image belongs to forest area. Future scope. This application can be further enhanced by using inverse fast Fourier transform algorithm for detailed texture feature extraction, and also used to identify the types of soil in desert areas and types of forest. It is used for further classification of the forest, and also for increasing the accuracy and reducing the time, we are using crossbreed fuzzy C-means clustering algorithm. Then for a higher classification result, we are going for future work. Then thank you.
Thank you, Manjula.
Yes,
It was a
sir.
nice presentation. So now it is open for all the audience to ask their questions.
Can you visit the slide 8?
Yes, sir.
Slide 8. Yeah. Okay, here my question is that initially you have number of images 10 and you set precision 1. Next one, so the next number of, so the accuracy is, can you explain why you choose precision or you get this kind of precision? I'm not actually understanding these things about precision and recall. Can you explain it? Can you hear me?
Yes, sir, I can hear you, sir.
Yeah, please.
And thank you, sir, for the question. So for precision, first we are taking 10 images. The precision is 1. If we are
Yes.
increasing the number of images, the precision would be 0.10. That should be reduced.
Why it is reducing? Can you explain?
Because we are dividing number of relevant classified images divided by total number of classified images.
I
If we are
see.
increasing the images, so that should
Mhm.
be, the precision should be decreased. Sir.
Yeah. Okay, I got it. Okay, thank you.
Thank you, sir.
Any other questions?
Yes, I have one questions. Simple questions. Yeah,
Yes.
in the same slide 8. Have you ever tried to consider using another performance matrix like F4 to find the balance between precision and recall?
Sir, in future work, I am testing those parameters, sir.
F1 score. Okay, thank you.
Oh, thank you, sir.
Any other questions? So my question is, Manjula.
Yes, sir.
Hello. So you have used that fuzzy C-means clustering and support vector machine classifier.
Yes, sir.
So what are the other classifiers are available?
Other classifier, neurofuzzy, neural network.
Have you analyzed
Then,
your work with those? I mean the results of those classifiers.
no, sir. I won't analyze now, but I can surely try it.
Because you have used one classifier, you have to compare also with other classifiers how your data or how your classifier data is better than those data or outcomes.
Okay, sir. I can.
Okay.
Okay, sir. I can done, sir. Okay, sir.
Okay. Anyone would like to ask any other questions? Okay, thank you, Manjula. It was a nice
Thank you, sir.
presentation. So there are the good scopes are available for further improvement of your work. Thank you all.
Thank you, sir, for the comment.
Now over to Dr. Muhammad Azam Hussain.
Sir, I want to request you to please, all the presenter is completed today, 5 presenters today in this session, and 1 is not attending. So I request you to conclude the session. I hand over you to conclude the session.
Okay. Thank you, Dr. Muhammad Azam Hussain. So it was a nice experience for me. Okay, for the first time, in fact, we conducted such type of a live conference session through online. In fact, it is a coincidence that we all are in a distributed location. You are talking about the distributed computing. Now
Yes.
we all are in the distributed locations, fine, without knowing to each and other, and without looking at the faces of those who are presented. So we did a very good job as far as the presentation is concerned, as well as the question and session is concerned. So I am very thankful to the organizing committee of the Smart Cyber 2020, and particularly Dr. Ahmad Afsi, the Dean of International Faculty, who has invited me to join as a co-chair for this session. So thanks to entire committee members.
Yes.
And special thanks to Dr. Muhammad Azam Hussain, so the chair of this smart computing session 1. And my thanks to all the resource persons, authors who have given their high-end outcomes of research, fine. And they have given the faith on this conference. They have shared their thought, their ideas, fine. So it was a, very, very good interactive session. Everybody learned from each other. So again, thanks to the entire organizing committee, thanks to all the authors, fine. So I wish you all the best for more work on your area. And thanks to Dr. Muhammad Azam Hussain.
Yes. Thank you, sir, for your concluding remarks. I also appreciate all the presenters who from the different part took the part. And I know India is very early morning. You took the part. So I send our session also is streaming on the YouTube. So I send the link in the message. I don't know whether this link is working or not. If not, we'll send you in the email later.
Okay.
So you can see your presentation on the online, and the stream YouTube is going also. I don't know whether you are aware of it. So thank you. Let me finish today session. And I hope afternoon we have a other session. I hope all you are going to join there. Thank you very much, sir. Everyone.
Thank you. Have a good day.
Bye.